The $9 billion mistake? Why America's grid is failing. In the first quarter of 2026, a shockwave ripped through the largest electrical grid in the United States. Wholesale power prices in the PJM Interconnection, a grid that serves over 65 million people across 13 states, surged by a staggering 76%. To the general public, this looked like a standard inflation hike. But to energy economists and power transmission engineers, it was a massive, flashing warning light. The American electricity grid is no longer just domestic infrastructure. It has become the central bottleneck of the global economy. The culprit? The explosive, relentless rollout of hyperscale AI data centers. Tech giants aren't just building warehouses, they are building digital cities that demand gigawatts of constant, uninterrupted power. But there is a fatal flaw in their master plan. You can have all the silicon chips in the world, but if you cannot physically move the electricity from the power plant to the server rack, the entire system grinds to a halt. Today we are going to look at the physical reality of the AI energy crisis. We'll look at the hidden civil engineering nightmares holding back grid expansion, the global supply chain vacuum draining the world of critical hardware, and why this infrastructure deficit is creating massive, institutional-level imbalances in the global markets. Generating electricity is rarely the problem. The true crisis lies in the transmission and distribution networks. When a tech company decides to build a 1,000-megawatt data center, they often select land far away from existing power sources simply because the real estate is cheaper and the water rights are easier to secure for their cooling systems. But connecting that facility to the grid is a monumental feat of civil engineering. To build a new high-voltage transmission line, engineers must first secure and clear right-of-way spans, often requiring the meticulous clearing of 20-meter corridors through complex topography. This alone is a massive logistical operation before a single ounce of concrete is even poured. Then comes the structural reality. You cannot just string up cables. You are engineering colossal steel structures that must withstand sheer wind loads, ice accumulation, and seismic activity. You are conducting deep soil testing to engineer foundations capable of anchoring these massive towers safely to the earth. The tech industry moves at the speed of software. The energy sector moves at the speed of steel, concrete, and regulatory permits. Right now, the United States has enough proposed energy projects waiting to be built to double its existing power capacity. But they are trapped in what is known as the interconnection queue. The average time from project application to commercial operation has skyrocketed to over 8 years. And even if a project clears the regulatory red tape, it hits a wall of physical hardware shortages. The global supply chain for heavy electrical components has completely fractured under the weight of AI demand. Consider the large power transformer, the beating heart of any electrical substation. You cannot operate a high-voltage grid without them. Currently, the industry is facing supply shortfalls of up to 30%. Lead times for these massive pieces of equipment have stretched beyond 128 to 144 weeks. That is nearly 3 years of waiting for a single piece of hardware. This is where a domestic U.S. infrastructure problem becomes a global crisis. The American tech sector's projected $400 billion capital expenditure is acting like a massive vacuum. U.S. data centers are effectively hoarding the global supply of generators, transformers, and specialized high-voltage engineering talent. Because of this, a power transmission megaproject in an emerging market can face multi-year delays simply because the required step-up transformers were outbid by a server farm in Virginia. The U.S. grid's desperate need for expansion is siphoning critical infrastructure development away from the rest of the world. When physical infrastructure bottlenecks this violently, the economic fallout bleeds directly into the financial markets. We aren't just talking about a $9.3 billion surge in costs passed down to everyday consumers in the PJM region. though that is happening. We are talking about macro-level shifts in global liquidity and asset pricing. For institutional investors, the data center boom has created massive market imbalances. The unprecedented demand for raw materials, specifically copper for transmission lines and heavy electrical components, is fundamentally shifting global supply dynamics. When a sector requires hundreds of billions of dollars in physical infrastructure just to sustain its baseline operations, it acts almost like a macro-level fair value gap in the commodities market. Price action violently reprices to accommodate the sudden, undeniable demand for physical hardware. Capital is rotating. The smart money realizes that the true bottleneck to the artificial intelligence revolution isn't processing power. It is electrical power. And whoever controls the physical infrastructure, the right-of-way corridors, the step-up transformers, the high-voltage substations, controls the future of the digital economy. Return to the cinematic drone shot of the transmission lines stretching endlessly over a mountain ridge at sunset. The 76% price surge we saw is not an anomaly. It is the new baseline. Until we drastically rethink how we manufacture heavy electrical components, how we permit transmission lines, and how we physically move power across continents, the grid will remain the ultimate speed limit on human technological progress. Subscribe for more infrastructure analysis. We are building the most advanced digital brains in human history, but we are plugging them into a nervous system that was designed a century ago. Something has to give. If you want to understand the physical realities shaping our global economy, hit the like button and subscribe. In our next video, we'll be breaking down the exact mechanics of how high-voltage substations are engineered to keep whole cities from going dark. Until next time.